Hello student, today I am going to discuss about the topic queue in data structure. So in this presentation I am going to cover the topics like what is queue and its operation and its implementation procedure by using arrays. Now let us see what is queue. So before that we should know what is data structure. So data structure can be defined as it is a way of organizing and storing data in a computer so that it can be accessed and used efficiently. In the sense, actually the data structure deals with how efficiently the data can be stored in a memory and how efficiently it can be accessed and manipulated. And as we all know that data structures can be classified as a two type. One as a primitive data structure, so another one is a non-primitive data structure. So in a primitive data structures like character, integer, boolean and float. So this we say it as a primitive data structures. Non-primitive data structures are of two type. One is a linear data structure and non-linear data structure. So linear data structures are stack, queue, arrays and list. And non-linear data structures are trees and graphs. So this is non-linear data structure. So here what I am discussing that belongs to the linear data structure. In a linear data structure, the instructions are executed in a sequential manner. Now let us see what actually the queue data structure is. So now we can define queue data structure as it is a special type of a data structure where elements are inserted from one end and elements are deleted from the other end. So the end from where elements are inserted, so that end we say it as a rear end, and the end from where the elements are deleted, so that end is called as a front end. So queue is referred to be as first in first out data structure. So we say it as a queue as FIFO fashion. Now it's like let's see the real life example of a queue. So in this you can see the people waiting in a queue to purchase tickets. So there are 5 persons are waiting in a queue. The person who is standing in front of the queue will be issued first. In the sense the ticket will be issued first to the person who is standing in front of the queue. And similarly the person who has standing in the next, so they will be getting the second ticket, and the third person is going to get the third ticket, and the fourth person is going to get the fourth ticket. Like that the last person is going to get the last ticket. So this is how our queue is going to work. Now let us take another example related to the queue only. So that is the traffic. So as you can see in the picture, so there are 4 cars are there in a road. So the car which is in a front, so that has to be moved first, and which is in a second, so that has to be moved first, and which is in a third, so it has to be moved third, and similarly the last one, so it has to be moved last. So this is how our queue data structure is going to work. Still we will take one more example related to this real time example. So as you can see in the picture, so this is a library counter. So queue has been maintained here to issue the books. The person who is standing in the front, so their book will be issued first, and similarly the person who is standing at the end, so their book will be issued at the end. So this is actually how our queue data structure is going to work. Now let us see how we can pictorially represent the queue as. So here we can see the pictorial representation of a queue. So there are 2 ends, one is called as a rear end, another one is called as a front end. So according to the definition, so elements are inserted through rear end. So this end we say it as a rear end. So this is called insertion, in the sense elements are inserted through the rear end. And similarly deletion, so deletion is always done through front end. So this end we say it as a front end. So insertion, it is also named as NQ operation, and deletion it is also called as DQ operation. So through rear end elements are inserted, and through front end elements will be deleted. So this is how we can represent queue in our data structure. Now let's see what are the operations that can be performed on queue. So as we had seen in our diagram, so we can insert an element, that's insertion is possible. We can insert an item into the queue, and then we can delete an item from the queue, and also finally we can display how many contents are there in a particular queue. So once again I repeat, so the insertion, deletion and display, so these are the common operation so that can be performed on queue. Now let us see some of the application of queue data structure in C. So already we had seen some real life examples where the queue concept is being applied, and also we can say that in our call centers the same queue concept has been used, and also queues are widely used as a waiting list for a single shared resources like a printer, and in our disk and in our CPU scheduling. And also queues are used as a buffer in most of the application like in MP3 players and CD players, and also it is used to maintain the playlist in the media player in order to add and remove the songs from the playlist, and they are also used in our operating system for handling the interrupt. If any interrupt occurs, so that can be handled through this concept. Okay. So in the sense, in our operating system there will be a ready queue. So whatever the process are there, so that will be arrived first to the ready queue, then it will be assigned to the processor for processing. And similarly another application is managing website traffic. This is also implemented based on the queue data structure itself, and in our network like in a routers and in a switches, it requests handling on the network. So these are all different application of queue data structure in C. Now let us see how many types of queues are there. So there are 4 different types of queue. One is simple queue, double-ended queue, a circular queue and priority queue. So these are the different types. So simple queue, by name itself indicating that here insertion and deletions will be done through 2 different ends. Okay. In a double-ended queue, once again insertion and deletion will be done, and circular queue, here also insertion and deletion can be done, and in a priority queue once again here also insertion and deletion operation can be done. So in detail we will discuss in the next presentation. Thank you.